last week for seniors this week. So this is the last class. Oh, let's see. I need to get my calendar updated. So yeah, Monday and Wednesday is the only class periods we have this week. It is a B day Friday. So any seniors that are like scrambling and trying to get last minute assignment in, come in Wednesday. You'll have first priority for my help if you need help getting anything done. So come in Wednesday, and we can knock out whatever you need help with, because I want seniors to get out of here on a good foot, on a good note, and especially if you need your grade up and finals. You don't want to make a 30% on the final next week and suddenly a passing grade becomes a non-passing grade. Well, we don't want that to happen at all. So we want to grade as high as possible going into the final. And I want you to do well in the final. It's all about the stuff we've been learning about how to program, about Python, about programming in general. So the final will be next Monday for the seniors in this class. But for the rest of us, we got this week, we got next week, and then the week after that is finals week. So there's not a whole lot of time left for any of us. If you got missing items, come on Wednesday. Seniors may not need my whole hour, I don't expect. And if you need help, come this Wednesday. Let's get some things turned in. I don't want anyone to fail this class, but right now it looks like I'm going to have a handful. Just one handful. I don't think it's going to be two handfuls, but there's going to be a handful of students that may not pass if they don't get some things done. And I'm not assigning any more programs, so it's not like I'm going to stack another program on here right at the end of the semester. This last month or so, I don't do that, because I want to give you a chance to get caught up on any of the ones you're already missing, and there are still quite a few missing throughout the class for some students. So I did take the 6.03 program, which was optional, the last program we had. I said, if you want to do it, I'll replace your lowest grade from the previous programs with that grade if it scores higher than your other grades. But otherwise, you just don't have to do it. It's optional. So I have gone into Hack and put that as excused for you. But if you do want to turn that in and it replaces one of your other grades, then I can undo that if I need to. So not a problem. So, all right, guys, let's take a look at what we have this week. Hope you had a great weekend. I did make it to see the new Marvel movie, the new one. What do they call themselves? I keep wanting to say the Bald Knobbers. That's not it. But anyway, yeah, no, the new movie. It's a very different kind of Marvel superhero movie. But it's interesting. Marvel does a good job telling stories. They really do. Thunderbolts. Thank you, Elijah. I knew somebody had it right on the top of it. My brain was not pulling it up this morning. Okay, got it up on the screen. Let's go to our grade screen and scroll down. All right, you should have turned in so far in Module 7. This is our last module, and we're talking about the cybersecurity side of computing, because that's a huge part of life in computers, and just a part of life because there's hackers out there. There's all kinds of craziness, and so that's what we're finishing up the year with. You should have the first two assignments done in Module 7. Maintaining cybersecurity was 2 weeks ago, and then last week was intrusion. That should have been turned in by yesterday. So this week we have cyber attacks. This will be the last assignment for seniors. So, if you need to redo any assignments, you can do that as well. I want you to do as well as you can. If you go back to redo an assignment and it says you're out of attempts, just email me. I'll reopen it for you. So let's nail this. Get 100% this week. So pay attention. Let's get our cyber attacks. And seniors, you're excused from 7.04. You won't be doing an assignment next week because you're not here. It's not required for you. So seniors, I will make sure this is excused and you do not have 7.04 that you're responsible for. Okay, cyber attacks 7.03. Let's move to our activity screen and look at the cyber attack lesson. What's the difference between a passive and an active attack? That's a good question. I mean, we guess we could talk about that. Some cyber criminals quietly attempt to gain access to valuable information like credit card numbers, usernames, and passwords And these are known as passive attacks because most of the time they do not leave a trace they were even there. Others seek to cause havoc by seizing and destroying vital system resources. So how can you recognize an active versus a passive attack? Well, during active attacks, hackers have unauthorized access to private information on computer systems or networks. And oftentimes the victims are immediately aware of the attack because your computer starts doing really crazy stuff, right? These attacks might involve viruses or malware, denial of service, or password cracking. The attacker might even seek a ransom or want revenge for being fired from a job. Let's see, you've probably heard of viruses and malware, password cracking. But let's talk about this denial of service for those of you who are not familiar with that. A lot of times, a website may get attacked by a group of hackers or an individual hacker with a denial of service attack. And what that is where they either use one computer or sometimes they'll use a network of computers to all send requests to the same website at once. Thousands and thousands of requests to this website and basically try to overwhelm the website where it shuts down because it's getting so much request for information at the same time that it cannot process that quickly. And it'll shut down, or you'll get that error when you try to go to that website because the server just cannot handle how many people are accessing that website at the same time. And a lot of times it's one hacker and he's got a network of computers, or he's got a bunch of, you can set up virtual computers and you can set up, all these virtual computers attack. That's called a denial of service because basically when I'm trying to go to the website, I can't access it because the server's overwhelmed. So there's a denial of service. So you'll hear about it though sometimes on the news, a denial of service attack. Basically, they're just overwhelming some website that it cannot process all the requests it's getting. Then there are passive attacks. Now these tend to be more subtle. Here the criminals gain access to confidential information, but they try to avoid detection for as long as possible. They try to get into your network and they're not trying to like put viruses and stuff that pops up on screen and people know they're there. But they want to get in there and try to find files that they can steal. And from here, they typically sell that information on the dark web. I know I have some software that I subscribe to, and I get notifications all the time. Your information was found on the dark web. And a lot of times it's just my old emails I don't need anymore. But occasionally they got my new email, and that's part of the reason I get all these spam phone calls is because they've got my information out there they're selling. My name and phone number at least, and my email address because I'll get some crap email. How they do it. Passive attackers use untraceable accounts or public workstations with false credentials to cover their tracks. Right? Go to the library or one of these internet cafes. Some sophisticated attackers use internet service providers that specialize in offering anonymity to their users. So there are some internet service providers that will help you hide on the internet where people don't know it's you. I'm sure they mean that they're doing it ethically, but let's see. Oh, did you know? Always some interesting did you knows. A script kiddie. That's a nickname for person. A script kiddie. That's someone who uses hacker tools, but doesn't always know what they're doing. They're like a newbie, right? Someone that just trying to learn how to hack and they're not very good at it. Script kiddies attacks might not have a specific target or goal except to gain attention. They're just wanting people to know, hey, look, I know how to hack. Technology has made it easier for script kiddies to obtain sophisticated tools capable of exploiting system vulnerabilities. Sadly enough, there are hacking programs available out there on the net, and people are finding them and creating new ones. This means even script kiddies can launch sophisticated cyber attacks because the necessary information is at their fingertips. It's important to remember that script kiddies can get into just as much trouble as a seasoned cyber criminal. Yes, they can go to jail too. Get caught hacking there. Do enough, you could certainly spend jail time. Insider versus outsider threats. So potential security threats lurk around every corner. A security professional's job is to recognize and halt the threats. Right. So let's look at the difference between an insider and an outsider threat, because those are certainly different. Insider threats come from within an organization. It's someone that already has a password in there, and maybe things are going bad for them. Maybe they're just trying to steal money. Maybe they think they're going to lose their job, and so they're doing damage. So the outsider threats are from those that are not associated with the organization. Some random person out on the internet, perhaps. Insider threats include negligent or criminal employees. They can also include business partners or former employees trying to get revenge. Outsider threats come from cyber criminals, maybe a competitor, or maybe a hacktivist, depending on what kind of business you are and they're trying to hack in there. What's the motives? Insiders are motivated usually by financial gain or personal revenge. Outsiders are motivated by financial gain or the thrill of wreaking havoc. Some people just like to be buttheads. And the methods. Insiders take advantage of employees who forgot to log out of their workstation, or else they use credentials to obtain private information. Outsiders use social engineering, electronic data theft, DDoS attacks. See, that's a denial of service attack using multiple computers. It's a DDoS. It's a little bit different than just denial of service. It's a dedicated denial of service, which is where they do a whole network of computers, not just from one. And malware. So the methods of security threats, insiders versus outsiders. All right, page 3. Knowledge check. All right, knowledge check already on page 3. Let's compare the types of cyber attacks. A passive attacker leaves behind a trail. True or false? Put that in the chat. We got a few minutes here. We can take the time to answer these live. There's only 4 questions. If they're a passive attacker, do they generally leave behind a trail? This says they do. Is that true or false? T or F, if your fingers are not warmed up enough, you want to hit one letter. T or F. Brandon's on top of it. She says, no, the passive attacker, generally, they try to get in and steal information and slip out without being noticed. Right? They're not trying to do it for attention. They're trying to sneak in and out. Let's see, an outside attacker already has ready access to the company resources. True or false? Outsiders already have ready access. Oh, yeah, false. Right. No, the insider would already have ready access. Outsiders got to figure out a way in. Oh, wait, did I put... Oh, I put true. I thought I wasn't paying attention. I thought it was true and false, true and false, true and false. They switched it up with me. False, right? It is not. All right. They're doing false and true on me. An insider attack could come from a current or past employee who has access to systems resources. Yeah, this is just the opposite of what we're talking about. See, this is the insider. Yeah, that's true. True is on the bottom. I got to pay attention. Active attacks tend to involve viruses, malware, denial of service, or password cracking. Not a passive. We're talking about active this time. Yeah, absolutely. True. The bottom one. You bet. They're malicious and damage system resources. Page 4. Everything is at risk. Discover how hardware, software, data, and networks are all susceptible to cyber attacks. Okay, software. Software is often the number one target when it comes to attacks. So it's critical to do those updates. Your computer wants to do all these updates all the time. Different software wants you to update it all the time. But that's usually to install security patches. Most of the time, I would dare say, when you're getting updates to different programs or updates to your operating system, it's because somebody has hacked into it or somebody has found a way to hack into it. And so the software developer has had to write some code to patch it, to fix that hole where people can't bust into the software anymore. That's what most of these updates are going to have. Sometimes there's an error in the software, and they're needing to just fix an error where it works right. But a lot of times, there is some additional security patches they're having to update. So that's why you want to do that. Criminals often hijack outdated applications to steal or cause damage. People that don't update it are more vulnerable. Software could be your internet browser or outdated antivirus software. You got antivirus software, it should be updated daily because there's always new updates to that. Just general applications, utilities, operating systems are big ones. It's those Windows machines that will update all the time. Hardware. Software tends to be targeted the most, but hardware is also vulnerable. Older PCs, laptops, and notebooks don't have a lot of the built-in security features that now come in the newer ones. They might not have the latest firmware. That's permanent software that's programmed into a read-only memory. Or they might not have self-encrypting hard drives that you get now installed. These features don't prevent threats and attacks 100% of the time, but they improve the security of business and personal computers. Examples of hardware include your CPU, which is your central processing unit, random access memory, which is RAM, and your hard drives. That's some of your hardware. Data. Sensitive data like credit card numbers, social security numbers, passwords. Those are all very alluring to criminals because if they can get that kind of information, they know they can squeeze some money out of it. Data that's not been encrypted is a common target. What do cyber criminals do with the data they steal? Well, they either exploit the data for profit or they sell it on the dark web for a profit, right? The dark web is a big marketplace for criminals looking to buy and sell personal information. Network assets. Criminals want to exploit routers and unmanaged computers connected to private networks. By doing so, they can freeze entire company and government assets remotely. So if you got some computers that are not being used on the network, they probably should be turned off or unplugged. Network equipment is always considered susceptible. That's where your routers and your firewalls got to be used to deter the cyber criminals from entering private networks. All right, page 5. The CIA triad. No, we're not talking about the Central Intelligence Agency, federal government. It's not the government. Data protection is serious business. What can be done to make sure businesses and organizations have proper safeguards? You might have heard about the CIA triad, but chance not. CIA stands for confidentiality, integrity, and availability. It's 3 cornerstones, basically, the CIA triad. Confidentiality, integrity, and availability. The CIA triad is a security resource that's been created for businesses and organizations to guide their IT practices. So let's learn more about what the CIA triad looks like. So information security. So integrity ensures that online information is trustworthy and accurate, right? What good is it for you to pull information off the internet if it's wrong? Any data that moves around the internet can be changed. So this could pose problems for those who depend on it being reliable. So you need to protect your information, make sure the integrity of the information remains, that it's accurate, that people haven't changed the data to be false. Availability. That ensures that the data is available and accessible to satisfy business needs. When someone needs to pull up this information, pull up this account, pull up this item, it's there. Availability focuses on basic hardware, allowing other areas of online security to run smoothly and without interruption. And then we have confidentiality. That's the set of rules limiting access to certain information, right? Only certain people should be able to access the credit card information, account numbers, social security information. These rules prevent sensitive information from landing in the wrong hands. So that's the 3 key pieces of information security. You're going to need to make sure that information is confidential, only accessible by those who need it. Make sure that it's accurate, there's integrity to it, and then it's available when needed. All right, page 6. Implementing the CIA triad. So confidentiality. That protects information through the use of passwords, account numbers, verification codes, and other precautionary methods. There's several ways to ensure the confidentiality of data, but the most widely used is cryptography. So cryptography has been around for hundreds of years. Let's define it. That's the study of secure information techniques that allow only the sender or the intended recipient of a message to view its content. It's like having your own little secret code, right? You transfer the message into a secret code, and only the person on the other end has the secret code to undo the message. Like when you're a kid, you could do that. The pigeon cipher has been used to encrypt secret messages throughout history. It is the most basic form. So plain text is converted into ciphertext, which is unreadable for humans. So here, try it for yourself. Can you decode? And I really like this pigeon cipher. Here's the encoded message. Let's see. Let's make it bigger. No, that's just talking about it. I'm gonna make this bigger the screen because I want you to see how this works. This is a pretty cool. I'm gonna keep it down there. Hide the code right now. You see, you got like this, looks like a greater than sign with a little dot in the middle. And then you've got this square, except it's missing the left side, the dot. You got this little two-sided shape. You got this two-sided shape with a dot. So some of these, some have dots in them and some of them don't. Well, here's how it works. You make two tic-tac-toe boards and then two X's. And then the second tic-tac-toe board, you put dots inside all of the squares. And on the second X, you put dots inside all the squares. And then you just write out the alphabet. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. And you got to do them in this order. So the person on the other end, when you send them this message, they can decode it. So first we have the left side right here. This is an X. See, because it's the triangle type shape that has the dot in it. It's open to the left. That would be this one. X. Then you got to find the square that has the open side on the left with the dot. So that's an M. This has the dot. See, the next one is the backwards L without the dot. So that would be the top part of this tic-tac-toe board where the A is. So that's an A. See, that's an R because it's this corner down here with a dot. Here's the top, U with a dot. So it's not the B. The B doesn't have a dot. You got to go, it's the K. This one does not have a dot, so it's the S. So X marks, I'm sure this is the spot, right? X marks the spot. But you can use this pigeon cipher to send secret messages to people as long as they know what you're doing. So you can send this whole big long letter if you want and create it in pigeon cipher and send it to your friends and have your own little secret back and forth. Did you crack the code? X marks the spot. So I really like the pigeon cipher. It's kind of a cool method. It's been used for a long time. But if someone hasn't seen it and don't know what you're doing when you send this, it looks like some kind of alien tech or something. Like, what in the world is that? Yeah, it's pigeon cipher. All right, let's talk about integrity. That was confidentiality. Integrity can be protected using several methods. Regular backups. That way, if information gets changed, you can go to the backup and pull the original information out there. Time stamping. The current time of event recorded by a computer. Electronic signatures, just a few examples. Cybersecurity experts also use hashing algorithms. That's a function that converts a data string into a numeric string output of fixed length. So every thing that you send, all the numbers be sent to 8 characters or whatever. The output string is generally much smaller than the original data. Certificates, digital signatures, non-repudiation, the assurance that something cannot deny something to check the integrity of data. And the availability is implemented using data backup, patching, and redundant systems. Redundancy guarantees fault tolerance. That means that when a primary system fails, the secondary system is available to continue delivering those functions and services and access to that information. So the bottom line is the CIA triad looks different depending on who's using the system. It's because different organizations have different policies. For example, a school might have a different data protection requirements than a manufacturing company. right? We're protecting student information, grades, all that kind of stuff. Where a manufacturing company may be protecting how you build something, trade secrets, employees' social security numbers, all that kind of stuff. But each should have the same interest in ensuring data. Make sure it's secure against any attack or damage. All right, that is the end of the lesson. It says complete the reading. Make sure you understand the concepts, and let's look at the quiz. Start. Which of the following is the best description of a passive attack? Which typically motivates former employees to threaten the security of a computer system? Which of the following is the number one target for cyber attacks? Which security model consists of confidentiality, integrity, and availability? And what is cryptography? There you go. 5 simple questions. Last assignment for seniors. Just a reminder, seniors, this is it. Get this assignment done. There will be no more assignments. And finals are next Monday if you need to be here. I will send emails out about exemptions on Friday for seniors. Everybody else, we're almost to that point. We got just 2 weeks from Wednesday, I think, is this class's final. So we're going to be talking about exemptions next week and make sure you get everything in. It is an A day Wednesday, a B day on Friday, though. So we've only got one class this week. So come if you need help. If you're still missing some programs, let me help you get those in. Let's get those grades up to passing. There's less people failing now than there were 2 weeks ago, which I'm happy. There's about half as many people failing now as there was 2 weeks ago. So that's great. We're getting some things turned in. We're getting there, guys. We're getting there. Don't give up. All right. If you got questions, you can hang around. But otherwise, you got time to go get you some breakfast for your next class.